Okay, so a long question to finish with here, and it's split into parts. So again, just take your time with it. See what you can do. Part A: the first two terms of an infinite geometric sequence. So infinite means that the common ratio is less than 1. It's kind of like a fraction, like half, thirds. Each term gets smaller and smaller. And because it's geometric, we know that r equals the ratio of successive terms. So we can just dive straight into this part here. It's 3 log to the base a of x divided by 4 log to the base a of x. Okay, so there's no log rules needed here. This is log to the base of a of x, log to the base a of x. So that means r is just simply 3/4. Show that the sum of the infinite sequence is 16 log to the base a of x. Log to the base 4. Oh, sorry, my bad. So that's log to the base 4, log to the base 4 there. It doesn't matter, as long as they're the same base, we can just cancel them out. Just my eyes, I'm getting very old. Okay, so now infinite sum for part B. Again, the formula book has this stated. So you just reach for the formula book. You should really know this without too many problems. So u of 1, 4 log to the base 4 of x divided by 1 minus 3/4, which equals 4 log to the base 4 of x divided by 1/4, which is indeed equal to 16 log to the base 4 of x. So even though it's a long question, it's towards the end, you pick up 5 marks pretty quickly. So one tactic when you do a long test is to scan all the questions, and especially the long ones, see if you can get marks for certain parts of it. Okay, the second part might be a little bit harder, but let's just grab this. I'll just copy it. Okay, let's see if we can put it onto this page now. Make it a little bit bigger there. Okay, the first 3 terms of an arithmetic sequence are this, this and this. Okay, so if it's arithmetic, then we have a common difference. So d is equal to u2 minus u1, which is equal to u3 minus u2. Take any 2 successive terms and subtract them. So I haven't even read the question, but for sure it's going to be asking us about d. So let's do the first idea here. Log to the base 4 of x over 4 minus log to the base 4 of x. Now we do a log rule. Okay, and when you do that, you can just take your time with it. And can you see that this actually just gives us -1? Okay, so log to the base 4 of 1/4 is 4 raised to what exponent gives 1/4, and it is indeed -1. Alright, so we've got d here. Now we'll go read the question. C, find the common difference d, give me your answer as an integer. Okay, so we've done that. I've done all these parts here, that's great. Show that the sum of 8 terms. Okay, so we've got a certain total we're heading towards. So it gives us the answer, which is fantastic. That's helpful because it means we can just shape our working out to try and get towards that answer. Okay, so let's just write this down, what information we've got. We've got u of 1, d, n. Well, n is definitely 8, d is -1, and u of 1 is log to the base 4 of x. Log to the base 4 of x. So now we reach for our summation formula. Now there's 2 summation formulas. One relies on you knowing the first and the last term. One relies on you knowing d and n. So I'm going to do this second formula, n over 2, 2u of 1 plus n minus 1 times by d. So substitute 8, 2 log to the base 4 of x plus 8 minus 1, -1. Make sure you get the -1 in brackets because you know you're multiplying. So this is 4, 2 log to the base 4 of x plus 8 minus 1 is 7 times -1 is -7. And can you see that this is what we're heading towards at the top here? It looks like we've actually got exactly the format we need when we expand it. 4 times 2 is 8. Log to the base 4 of x, and 4 times -7 is -28. We got there without too much of a problem. So we've done the summation here. given that S of 8 is equal to 1/4 of the sum of the infinite geometric sequence, find x. Okay, S of 8 equals 1/4 s to infinity. So I'm going to write that down as a statement, put another page in there. So S of 8 equals 1/4 the sum to infinity. Okay, so we're just going to substitute some of our answers in there. Now it told us what S8 was. It's 8 log to the base 4 of x minus 28. That's equal to 1/4 the sum to infinity. And we've got an answer for the sum to infinity back here. Show that the sum to infinity is 16 log to the base 4 of x. Now can you see that actually this question relies on you not actually being able to do any of the other parts, because S of 8 is given and sum to infinity is given. So you could actually go straight to this last part of the question without doing any of the other questions. That's handy to know. Alright, so let's have a little look here. We've got log to the base 4, log to the base 4. It's handy to get those on the same side. So let's get those on the same side and take it from there. This is 8 log to the base 4 of x. I'm just going to tidy this up. 1/4 of 16 is 4. So bring that across, minus 4 log to the base 4 of x. Move over to 28. And now can you see that I've got a common variable here. I've got 8 lots minus 4 lots is 4 lots. Get it down to single logarithm. And now x equals 4 raised to the 7. And I can leave it like that. There's no need to write it as a single integer. So we just check to see if we've covered all the question. Okay, a to the p, where a and p are members of a family of real numbers. So it looks like we've done that part as well. And there we have it complete.